Alright, I'm going to redo my video on 8.4 to kind of make it a little bit better with as far as the graphs and everything go. So let's look at example 1, and 8.4 is all about the graphs of quadratic functions. Example 1, we're graphing a quadratic function. So we have the equation f of x equals x squared plus 2x minus 3. So one way we can graph this is make our handy dandy xy chart. Alright, we're making our handy dandy xy chart. So for instance, if we plug in negative 4 for x, we've got negative 4 squared plus 2 times negative 4 minus 3, which is going to give us 5. So we can pick any points. You ideally want points that are going to be simple points to compute. I like to do like negative 3, negative 2, negative 1, 0, 1, 2, 3. The book did, let's see, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. It doesn't matter really how many you do. Well, you wanted probably at least 5. It doesn't matter kind of where the points are, but I would kind of stick with those ones to make it easy. So let's see, we have negative 4, 5, negative 3, 0, 2, negative 3, negative 1, negative 4, 0 becomes negative 3 when you plug that in. 1 gives us 0, and 2 gives us 5. I'm not going to go over kind of how to do that because I feel like you guys know how to evaluate for a given x value. So we plot those points, and that's where we're going to get this graph on the right, that f of x, x squared, plus 2x minus 3. Plotting those points, what you can do is then, you sketch your line. We know it's quadratic, so we know it's parabola shape, and then just double check yourself on your graphing calculators. Alright, some quick vocabulary for quadratic functions. Again, this is stuff that you've probably seen before. We have a parabola. That's the shape of a quadratic function. It's that U-shaped function. The extreme point, so this is where we have our minimum or our maximum point on our graph, which what those are. Minimum point, that's going to be the lowest point on the graph. It's going to be a graph that opens upward. For instance, I'll do a quick sketch. Here's my xy axis. It's going to be a graph that opens upward, and it's going to have a minimum value at the bottom. It's important to note that your a, so your coefficient of x squared, is going to be greater than 0 in this case. Now, when a is less than 0, you have a negative function, this is where you have it kind of upside down u. Your highest point on your graph, up here you're going to have your maximum value. So we had our minimum, now we have our maximum, so our minimum will be somewhere around there, maximum there. This is when a is going to be less than 0. It's going to be a negative function. These minimum and maximum points are also called your vertex, and an equation to find the vertex, you find where your x value is. X is going to be negative b over 2a. Your textbook kind of shows how they came to that conclusion, how they got that equation. It involves using the standard form and then completing the square, lots of a's, b's. It's pretty awesome though. But that goes over, that's how you find the x coordinate of the vertex. The y coordinate, you would just plug that in. So you would have negative b over 2a, and then it will be f of negative b over 2a. This point right here would be your vertex. It's kind of algebraically in symbols what that means. Let's go over an example next. Alright, example 2, actually we're not going to go over the vertex yet, but we're getting there. So for example 2, we've got two parabolas here. First parabola, you see it opens upward, so that means that our a has to be greater than 0. And our function, as you see, it's right up here, it's kind of small, but it's 2x squared minus 8x plus 6. So our a is 2, our a is greater than 0. It opens upward in this case. So in this case, we're going to have a minimum value. So it's actually going to be right here is our minimum. And you can kind of see it. It's going to be the point 2, negative 2. This is one of our extreme points. But if you look at the graph on the right, this one opens downward. So that means that a has to be less than 0. It's negative, which you can look at it and you see it's going to be negative 2x squared plus 8x minus 6. Let me write these a little bit bigger for you. So the first one was f of x is 2x squared minus 8x plus 6. The graph on the right is f of x equals negative 2x squared plus 8x minus 6. So this graph, you see, it opens downward. we have our a is less than 0 in this case because it's negative, and in this one we have a maximum value up here at the point 2, 2. Alright, for example 3, we're going to graph a parabola using its vertex and its y-intercept. So we're going to take the function y equals 2x squared minus 8x plus 6. We're going to find the vertex first. So remember our vertex equation, x equals negative b over 2a. So with our graph, a is going to be 2, b is negative 8, and c equals 6. So let's plug it in. We have x equals negative 8 over 2 times 2, which is 8 over 2, or sorry, 8 over 4, which is 2. Now, this is the x-coordinate only. So we have to plug this in for x into the first equation to then get the y-coordinate. So y equals 2 times 2 squared minus 8 times 2 plus 6. So let's see, that's 2 times 4 minus 16 plus 6, which is 8 minus 16 plus 6, which gives us y equals negative 2. So we would say that our vertex, the point, would be 2, negative 2. Which what this would look like, well, we'll get back to this. Keep this, the vertex is 2, negative 2. Let's, on the next slide, we'll go over how to do the y-intercept. Alright, so our function from the previous slide was that y equals 2x squared minus 8x plus 6. We know that the vertex is going to be 2, negative 2. Now we're going to find the y-intercept. So to find the y-intercept, recall back from like your Algebra 1 days. When we do this, we set x equal 0. Because when it crosses your y-intercept, your x value right there is going to be 0. So plug in 0 for x, gives us y equals 2 times 0 squared minus 8 times 0 plus 6, which our y-coordinate is just going to be 6. So that tells us our y-intercept is the point 0, comma 6. Our y-intercept. You can quickly do this. You can quickly look at it because if you plug in 0 for the 2x term or whatever the x squared term and the x is, you know that this is just going to cancel out those two terms, and all that we're going to have left over is c. So really, you can jump to say that your y-intercept is 0, comma whatever your c value is. Make sure if it's negative, if it's minus 6 there, that would be 0 minus 6 as your y-intercept. If it's positive, it's 0, 6. So we know our y-intercept is 0, 6, and our vertex is 2, negative 2. Let's graph it on the next slide. Alright, if we look here at our graph, I already graphed it for us, I did it on the calculator, but we're going to kind of plot those points. So we know that the vertex was 2, negative 2. So over 2, down 2, you see that right there. That is our vertex at 2, negative 2, are also our minimum. And then graph your y-intercept. So we said that was 0, 6. So over 0, up 1, 2, 3, 4, 5, 6. It's going to be right here. That is your y-intercept, which was 0, comma 6. So if you graph those 2 points, you know that it's going to go from your vertex. Let me do a highlighter here. It would go from your vertex up to that point. It's going to mirror it on the right side, so you would just kind of sketch your line there just to kind of mirror it, and then always double check it on your graphing calculator. Alright, sometimes we're going to need to graph a graph parabola that does not have the middle term, doesn't have that x term. And you look at the equation in this case, we have the function f of x, or y equals x squared plus 1. Doesn't have b, doesn't have a b term there, or an x term. So first, this, as you can see, kind of see from the graph, it's going to be a little bit difficult. Not difficult, a little bit different. It has some different properties to it, but It's not hard. So first step, find the vertex. So we can see it from our graph, it's going to be 0, 1. But let's do it algebraically. So x equals negative b over 2a, which is going to be 0, or negative 0, just 0, over 2 times 1. But it doesn't matter because it's going to be 0. Plug that in for x. So y equals 0 squared plus 1, or just 1. That means our vertex is the point 0, comma 1, right here. Now, this is our vertex. It's also our min, and it's going to be our y-intercept as well. So we couldn't use the previous method that we just did, where we graphed a vertex and we graphed a y-intercept, because our vertex is our y-intercept. So we need to find two other points on our graph, or on a line that we can graph, and then kind of shade our line in on those. So why don't we pick, let's make it easy. Let's let x equal 2, and then let x equal negative 2. So let's do x equals 2. That gives us that y equals 2 squared plus 1, or that y equals 5. So that gives us the point 2, comma 5. So graph that. It's going to be right about there. And let's do it for negative 2 as well. So y equals negative 2 squared plus 1, which again, y equals 5. So we have the point negative 2, 5. So we graph that right about there. Now, ignore that we have a line, but if we didn't have a line, we would just be connecting now those 3 points and even kind of extending it to make our function. And then obviously check it with your calculator as well. Alright, sometimes graphing the vertex and the y-intercept makes it a little bit difficult because they're very close together. So if you look up here, you can see that our y-intercept and our maximum are going to be very close together. It's going to be really hard to get a good picture of the graph, so you want to graph something else. In this case, we're graphing these x-intercept, or x-intercept points. We're graphing those as well. So then it becomes, well, how do we find those points? So let's look. We have our function, negative x squared plus x plus 6. So we want to graph this. Well, we know how to do our vertex. We know how to do our y-intercept. So we're not going to worry about those. We're going to worry about the x-intercept points. So we want to set this function equal to 0, because to find the x-intercepts, that's when y equals 0 right here. So 0 equals negative x squared plus x plus 6. Now, we want to factor this. What I want to do, because I don't like that negative there, move everything to the right side, so that we've got x squared minus x minus 0 equals 0, or minus 6, sorry, equals 0. We're just changing the signs, essentially. And now we're going to factor this. What can multiply together to give us negative 6, but add to give us negative 1. So it's going to factor into x minus 3 and x plus 2 equals 0. Set each of these equal to 0, which gives us x equals 3 and x equals negative 2. So these are points. They're not just these solutions or this what x equals. It's you're going to be your point, and it's going to be the point 3 comma 0, because remember it's when we set our y equal to 0, and then negative 2, 0. And so you can double check, this point right here is negative 2, 0, and this point right here went over 3 up 0, so that's 3, 0 as well. So when you have where this y-intercept and the maximum value or your extreme point are really close together, go ahead and graph your x-intercepts as well. And I believe that is some of the problems on the homework.